through here. Yeah, it does.
All right. Tēnā koutou, tēnā koutou, tēnā koutou katoa. No apati aho, ko Loveridge te whānau, ko Jolene aho. Ka nui te mihi kia koutou, tēnā koutou, tēnā koutou, tēnā koutou katoa. So, yeah, kia ora, my name is Jo Loveridge. I am coming to you from a place called Apati, which is in the Manawatu, 30 minutes north of Fielding. I am joined also with me. I'll just unpin myself.
Jo, I'm just going to try and hook you up to speakers. Sorry.
Oh, sure. I'll just press.
No.
All right. So I've just, wanted to introduce you to obviously Trish Bunting, and I'll hand it over to Trish to.
Kia ora. Yeah, kia ora. Good morning, everybody. My name is Trish Bunting. I'm based here in Christchurch, Otatahi, and this year I have had the privilege of being a Numicon consultant. My area is currently the South Island, so I am your point of contact. And I'll share my email address at the end. If you have any questions or any feedback or comments or need help with anything following Jo's presentation, then I'm the person to get in touch with.
Cool, thanks, Trish. Yes, I'll just pin my video just so that my screen's nice and big. Just like Trish said, Numicon consultant. So I've been doing that for a consultant for Numicon for the past 5 years. I've got 20 years teaching experience. Really enjoying my role and learning, concentrating on one area of maths. It's having nice to have a break from the classroom, but looking forward to heading back into the classroom sometime soon. All right, so I will share my screen. All right, so you've come to using manipulatives to support understanding in mathematics. Now, this little image here is obviously Cuisenaire rods, but it comes from the 660s album cover. So, yeah, quite lovely to have the Cuisenaire rods still seen. So, I'd like to start today by obviously looking, I looked at a few of the purpose statement in the new refreshed maths and stats curriculum, and I took out some key points, the purpose of maths and what is maths. Okay, so in maths, students learn to investigate, interpret and explain patterns and relationships in quantity, space, time, data and uncertainty. So notice the word number doesn't appear there, but the word quantity obviously could mean number. It's about learners engaging in tasks that promote curiosity through exploration. They state in the purpose statement that maths is a universal language, fostering collaboration, innovation, and mutual understanding. Students participate when they engage in mathematical thinking and communicating. And they talk about maths being an abstract, obviously the abstract idea. So the use of abstract vocab, symbols, tables, graphs, and diagrams. And then obviously within that, you've got the understand, know, do, okay? Learners doing, so the investigating, connecting, representing, generalizing, exploring, and justifying. So yeah, really excited about the new curriculum. I'd also just like to share with you what Numicon says maths is, okay? This is taken from the Firm Foundations manual. A great big conversation about relationships between quantities, events, and things themselves. And numbers have been invented, and measures of many kinds to help develop our mathematical communicating. Mathematical communicating involves a great deal more than just words. It's actions, gestures, drawings, diagrams, pictures, and symbols. All right, so that universal language of maths is coming through there. All right, so the New Zealand curriculum and the Numicon are saying the same message about what maths is. Okay, so now I'd just like to show you this symbol. And if I asked you, questions like, is this number larger than 10? Is this number less than, is it divisible by 5? Is it a prime number? Okay, so you're probably looking at me like, I have no idea what that symbol is. And some of you might know that it is the Chinese and Japanese symbol for 7. All right, so that feeling that you have when I'm asking you those questions, it's very hard to join in the conversation when you have no idea what I'm talking about. All right, so learners in your classroom are feeling the same way. Okay, so this, I can read 7, I can write 7, I can say 7, and I can probably count to 7, but that doesn't lead me to an understanding of what 7 actually is. All right, so this is why manipulatives are so important. It helps learners to have visualize what numbers actually are. So I'd like now to just go into the uses of a number. So this image shows the 3 uses of how numbers are used, okay? So we've got the nominal aspect, okay? So the name of the car. So we're looking at car 15. That's the nominal, okay? It's a name, just like an early childhood student. So it's the first way, or the first introduction to number for our littlies is generally that nominal aspect, okay? They're thinking themselves as a label. My name's Jo and I'm 4, okay? There's a label attached. So imagine a child, a teacher's counting a group of children. They're in a line and there's 5 in the line. She's counting to see how many there are. 1, 2, 3, 4, 5. And that child says, I'm not 5, I'm 4. So that's that nominal aspect. And that child has a nominal understanding of a number. And then we've got the ordinal numbers, okay? So car number 99 is in first position. So that's ordinal. And so when we're counting, just like I did before, 1, 2, 3, 4, 5, 6, that's an ordinal sequence, okay? I'm not counting to find out how many, all right, which is our next one, the cardinal aspect. So how many cars we see is to do with cardinality. And cardinality it's also to do with counting, because the last number I say is the total amount. But what I'd like us to realize is that counting's not the only way to find out how many. All right, so that's why I wanted to touch on subitizing, because in the new curriculum that's just come out, subitizing is it's key. It's one of the number strand there. Recognizing how many there are, all right, is really important skill to have. Well, sorry, it's an innate. We have an innate ability to recognize a quantity, all right. And at the 6 month, at 6 months, the check in the New Zealand curriculum says up to 5, that you can recognize a quantity up to 5. And then in year 1 up to 10, and then year 2, you can actually group objects in tens to recognize how many. Okay, so I'm going to flash up some dots, all right, and you will be able to obviously see how many, all right. Trish might just call out, how many do you see?
3.
Yes, you see 3. You did not need to count. Now this is obviously an innate ability. That pattern there looks like eyes and a mouth. So babies, as I might have taken that slide out actually. So that's what we call perceptual subitizing. We just see it, we know it, okay? And Brian Butterworth has done research into babies as young as 3 months old, okay? And that they can recognize the 3-ness of 3 without even actually knowing that it's 3. And Brian Butterworth's research was about children recognizing quantities of amounts. They can see more, okay? and they will always choose option 2 if they like it, okay? They will, so they can actually recognize larger and greater than, less than amounts without even counting. So what do you see and how do you see it? Okay, so I'm going to ask Trish to call out what she sees and how she sees it. Oh.
7.
Was that enough?
Yep.
You saw 7. And how did you see that, Trish?
So I saw 3 on the left and sort of 3 in the middle, and then just 1 on its own. Yeah. Oh,
Okay.
so 6.
Isn't that, yeah, and obviously if I was there in the room, I would be asking how others saw that as well. But what this is this is conceptual supervising, okay? Seeing parts that create the whole. And that is where we want our learners to be, that part whole thinking, okay? That numbers are whole, but made up of parts, okay? And that's a really hard skill that we're trying to encourage our children to do. So highly encourage you to get those dot talks out and asking children to what did they see and how did they see it. All right, so now, Trish, I'm going to show you a different formation of dots. And you're going to tell me how many you see.
6.
Okay, so you saw 6. All right, so there's a couple of things here to talk about here. That when it's in a line, it's harder to see that it's in a group, okay? I can also, when it's in a line, children are, are more than likely wanting to count, to check how many, okay? So that's why so numbers being isolated ones, all right, a string of ones is not helpful. We would rather children being able to recognizing how many there are instantly. And this statement from Gray and Tall, when students get stuck using counting on strategies to the exclusion of other more sophisticated strategies, we call this living in one's world. Students living here seem to have a continuous string of ones. This conceptualization may work at the foundation level, but does not hold up as numbers get larger and as students move to multiplicative reasoning. So these learners, when you ask them to count to solve how many, 1, 2, 3, 4, 5, 6, and then you say how many, and they have to go back and count 1, 2, 3, 4, 5, 6. They don't have that. They have poor cardinal knowledge. All right. Children with poor cardinal knowledge are not able to count on. They cannot hold that number and then count on. So it's much more effective for us as teachers for supervising. So bringing in supervising and recognizing what they see and how they see it. Now, this is where the shapes, the Cuisenaire rods and the Numicon shapes support that idea, okay? They help learners to think about numbers as whole entities, how they relate to each other and how as whole objects, and how then children can combine and compare whole numbers, okay, to make other whole numbers. And that's what calculating is. So I'm just going to stop share now. And I'm going to drop my laptop screen. I'll just go to full screen. And in front of me, I've got obviously a table full of equipment here. So I'll start with the Numicon shapes first. All right, these shapes are obviously designed like a 10 frame, similar to a 10 frame, but the 5 you can see is not all in a line. Just like I shared with you earlier about when numbers are in a line, it's not like, it doesn't look like it's in a group, okay? And that we would rather children supervise to recognize how many instead of counting to check when it's in a line. So one of the first activities for learners with these shapes is what do you see and what do you notice? Okay, so some responses would be, I see some with more holes and less holes. So greater than, less than. I see some with a sticky outy bit. All right, some's got a sticky outy bit. These ones don't have a buddy next to it, okay? And neither does this one. This one doesn't have a buddy with it either. I see a square. All right, I see a rectangle. So lots of, obviously, and I see colors, okay? The first activity that I'm going to share with you, obviously, is order. So ordering the shapes. And I'm hoping Trish will let me know if I've got them the right way around. Can you see them correctly?
Yes, looking good.
Thank you. And I'm hoping we'll be able to fit them in. I may have to move the 10. So order, you can see I'm starting from the largest and going down to the smallest, but if I was asking a child, let's order these from smallest to largest. All right, and then that's what we call our staircase, all right, a Numicon staircase. And these, some learners will put this like this, all right, but it's about every number starts with, every one apart from 1, start with a base of 2. So it needs to be flat for this. So this, when I take this orange shape for a walk, I can see that it makes the next shape. At the moment, they're just shapes, okay? Until the child recognizes that as 5, they are just shapes for them to compare, all right, and combine. All right, so as I'm going up, I'm actually proving by picking it up and placing it on that they actually make the same pattern. And I can do that too for subtraction as well, for taking away 1. So 9, I've made a 9 pattern here. If I take 1 away, oh, I've made the same shape, okay? I've made an 8. I'm going to take 1 away. 8 take away 1 is 7. So the colors, orange, light blue, yellow, light green, red, turquoise, pink, green, purple, and blue. The sticky outy bits, so these ones that don't have a buddy, they can all be stacked on top of each other, and they are what we call our warm colors. All right, and then all our evens are cool colors. Okay, so odds and evens. And then when I place them back into the staircase, I can then figure out a pattern that I've made. Oh, odd, even, odd, even, odd, even, odd, even, odd, even. So I've figured out, obviously, I've made a generalization that, or learners make these generalizations, that if in our staircase, 1 more, so the successor relationship, when I add 1 more, it's always the next shape. I can also say that these shapes have another pattern and that it's odd and even, odd and even. So so Trish, I'm going to hide a shape in my pocket and you're going to ask me questions to try and figure out what shape is in my pocket. Now, you're not allowed to ask me questions like, is it 6? Is it 9? Okay, you're going to use those questions like 1 more, 1 less, greater than, less than, odd, even. So go, Trish.
All right. Is the shape you have in your pocket, is it odd or even?
So ask me one question. Is it
odd? Okay. Is the shape in your pocket odd?
No. So that means I remove, all right, all of the odd shapes. And what's an odd shape? It's a shape that is not divisible by 2. And it's doesn't have a buddy there. So therefore now we've only got a few left, Trish. So what would be your next question that you could ask me?
Is your shape smaller than 6?
Yes, it is smaller than 6. Great question. So now we've only got 2 shapes left.
Does your shape have 2 holes?
No.
Is your
My
shape
shape
full?
is 4. Well done, Paki, Trish. Very good. I'd just like to share with you also an activity, how I said to you about numbers being abstract for learners earlier on. They need to be explicitly taught. Okay, so, and just like I've also shared that learners can think about numbers as whole entities. Okay, so this is a 5. How do I know it's 5? Because it's 1 more than 4. Okay, so then I would ask the child to create that pattern. And it's in the New Zealand curriculum, all right, in the first 6 months that learners can create patterns and group objects, all right, up to 5, I think it was in the 6th month. So this here, I can see I've created the pattern. I can check. I can see by putting that on top, I know that I've made 5. I don't need to count, okay, to say that I've made 5. But 1-to-1 matching is very important, all right? That 1-to-1 correspondence is important. So this is where I would ask the child to place them into the number track, okay? This is what we call a number track. It's not a number line because the line is not obviously below the number and it doesn't start at 0. So as the children are counting, I would encourage you to circle the group. 1, 2, 3, 4, 5. Okay, it's a lot clearer that as we count, our groups are increasing. Okay, and you can't see obviously the numbers, they're hidden, but that's a really great activity that you can, and then obviously they go and find it over here. I found 5. So numbers need to be explicitly taught. Okay, my next demo, that was it. All right, I'm going to share my screen again and just show you what I've just covered. Okay, so we looked at the staircase, all right, the odd and even, the warm and cool colors. So you can obviously see how order, pattern, greater than, less than, 1 more, 1 less, odd and even. All right, now I would like to just quickly touch on the rods. Okay, so I'm just going to stop share, tilt my screen down. All right, so Cuisenaire rods obviously they're completely different colors to the unicorn shapes. And you're going to learn why now. So what happens here, so I'll just quickly make the staircase so that you can see it's similar to what I've just shared you with the Numicon shapes. Okay. Oh, I know that I've missed one out because there's a bigger gap, and I can figure out, children can obviously figure this out. So order, instantly you can see order. So smaller, smallest to largest. Okay, you can see greater than, less than. And I can also take my 1 shape and take it for a walk. Okay, and see that when I add 1 more, it makes the next shape. Odds and evens are a little bit, you have to actually prove as to why it is odd. So if I took this yellow rod and I can prove to you that this is an odd shape because there's 1 on its own. So very helpful for having to reason as to why it is that rod. Okay, they have no segregations because, like I've keep saying to you is that we are encouraging children not to count. They're really great for that. Now, why are they coloured the way they are? And while I'm doing this, they were invented by Georges Cuisenaire. And he was a teacher, all right, and a music teacher. And he was always confused as to why learners found it hard to learn arithmetic. So addition, subtraction, multiplication, division. But in music, they could pick up a tune really quickly. All right. So he designed, went into a shed probably in about the 1920s. He first invented them and made centimetre equivalent wooden lengths. Obviously, now these are weighted. Okay. These shapes are weighted. We can put these into a pan balance. You may have some in your classroom still. All right. Because Gattegno, he saw Cuisenaire using these in his classroom and he said, these are amazing. And then he took them all around the world, this Gattegno man. Anyway, so here's the colours. This is the way they are, why they're coloured the way they are. So if I showed these, so Trish, can you see the colours clearly? And can you tell me what their relationship is?
So you've got red and you've got pink and you've got brown. So I can see that the red one is about half the size of the pink one.
Yes.
And the pink one is half the size of the brown one.
Well, nice. Okay, so that's showing quarters, isn't it? Because 4 of those red ones would fit across there. And it's also, like you said, showing the halves as well. All right, now this one here, the greens and the blues.
So once again, the little light green one looks to be half the size of the dark green.
Yeah.
The dark green, there's only a little gap, and I would think, looking at it, that the 3 is going to fit in that gap, that little light green one, to match the length of the big blue one.
Yeah, so Trish has used these. So did you notice that? She actually said 3. She's calling that one 3. Okay, so she thinks that if that's 3, then what would that green one be? I wonder. If that's one.
Yeah.
Yeah, so you can, do you see what I mean? That Trish, when students have been given the time to use these, it's not a barrier, okay? They can attach the number 3, they can attach the number 30 if they wanted. Okay, so that's showing thirds. All right, so 3 of these greens would fit across that blue. And then part whole as well. All right, 2 rods to make another rod. So quarters, thirds, and then this one showing
half.
Yeah, nice. Yeah. And generally, learners will go, oh yeah, I can see that. I know this one's 10, but then this one must be 5. All right. And then we've got the black and the white. Okay, they've changed it to off-white so that it's easier to see on white paper. But the real reason, obviously, it should have been white is because black and white have no color relationship to the others, because this is a prime rod. And what do we mean by prime? We mean the only rod that can fit across there equally is that one rod. Okay. Yes, there are other prime numbers in here, but that's just letting you know that that's the way why they've colored the rods the way they are. And yes, the colors are important too, which will come up on the screen. I can also play those games, like have it in just with the shapes as well. I could take away a rod and you could have to figure out which rod was missing. All right, or I can just remove a rod. All right, so Trish, which one do you think?
I'll put my glasses on for this, Jo. Looking closely at that, I can see the gap between the pink one and the dark green one is bigger, looks bigger than the one.
Yep.
So I think it's the yellow one that's missing.
Great. All right, so those sorts of games can be played with shapes as well. There's fairly bags that you can actually use. And it's, yeah, just about exploration. I've got some photos of what learners in my class used to make with the rods as well. All right, so I'll just go back, share my screen. All right, so just, yep, repeating there. They could mean 2, 4, and 8, 3, 6, and 9, 5 and 10, 7 and 1, or seasons. You can see the seasons there. Some obviously winter, summer, spring, and autumn, and same again, warm and cool. All right, so we've done the staircase. There's the colors there: white, red, green, pink, yellow, dark green, black, tan, blue, and orange. Okay. And you will see later on as to why, because we've got so many B colors in there. They've obviously got a capital B for blue, and they've changed that from brown to tan. Okay. So really neat. All right. Rods are fantastic. Another activity you can use with rods, a boat, is making boats with your learners. A boat is made up of any 3 rods on top of each other, with the shortest on the top and the longest on the bottom. What different boats can we make? Can we use all the colors? And what's the same about any 2 boats, and what is different? Patterns, you can see the patterns, and you can see the odd and even there for rods, how important they are. And then I was teaching in a rural school, so obviously horses were pretty mad. They were pretty mad on horses. Yeah, they're amazing. So why is this all so important, this hands-on learning? All right, it all comes back to Jerome Bruner's forms of representation. He termed them as enactive, iconic, and symbolic. Okay, they are now referred to as concrete pictorial abstract, or in the US, concrete representational abstract. Okay, so the very first, all right, learners make cognitive connections through action, okay, through first-hand experience. So the doing is really important. So there's an image of 3 apples, okay? Actually handling the apples. We can't always have apples in the classroom, all right? So that's why we've got counters and obviously Numicon shapes and yeah, all of your manipulatives that you have in your classroom to support that idea of what is actually happening, all right? Drawing what you've just done to embed, all right, to understand it more, and then to be able to understand when we do write those symbols in the language of maths, okay, that adding, when we actually are talking about adding, what are we doing? We're actually moving shapes together, aren't we? What we call combining, all right, and then showing that by drawing, using blocks, multi-link cubes. Yeah, it's so important, all right, that CPA is so important. CPA is not a linear journey, okay? Learning is not a linear journey, okay? Imagining a train going along, we don't leave the concrete, all right, once we've done it. We're actually going through all of the stages, going back through the stages, all right? And as learners with more experience, so older learners, there's obviously this idea that we need to get rid of manipulatives. All right. The manipulatives are there so that when we're teaching a new idea, all right, we're always thinking about how can we make this concrete for our learners, especially in fractions, okay, which I'll be sharing with you shortly. So maths, like we said, maths is a language, okay, and it can be confusing, just like the numerals. All right, we need to explicitly teach how could we make this concept of equivalence concrete, thinking about the concrete pictorial abstract. Well, we can use, the CPA, thinking about the concrete pictorial abstract plus language. How can we make that concept concrete? The use of the pan balance, all the shapes, okay, the Numicon shapes and the Cuisenaire rods are weighted. We can place them into a pan balance to show that they balance, okay? That this image here shows 2 tens, and when the shape is showing, they are equivalent, aren't they? They are exactly the same. But when the shapes change in the pan balance, that's a digital pan balance that you see up the top there, there's a 4 and a 2 and a 6 in the other one. They're not the same, are they? We need to, as teachers, use the correct terminology. It is worth the same, all right? Or we can actually start to say it is equivalent because they balance, all right? And equivalence, the meaning, the definition of it is equal value, different appearance. And you can see the actual physical sign that the learners are making. And in the New Zealand curriculum document, all right, it says that the equivalent sign is relational and that it shows that 2 sides of an equation represent the same quantity. Okay, really key that we're not just using the word same on its own. Same quantity, worth the same, equivalent, equal value, different appearance. So this here, this diagram by Haylock and Coburn, he calls it the making connections diagram. Now you can see there that down the bottom, concrete, pictorial, abstract, plus language. Okay, it's really made it quite clear that language is sitting on its own as well. All right, so that we're not forgetting to drop it off. Sometimes with the CPA, the language can be forgotten about. I've got, so the connections, many of these kind of connections contribute to learners' understanding, okay? So for children to developing an understanding of a concept, in number work can be thought of as helping build cognitive connections between these 4 components. Now, Haylock, I wanted to give you this Derek Haylock. It's come from the pink book, which I've got sitting here. I'm not sure if you can probably see my video, but I'll share it to you when I've shared my screen. To understand many mathematical ideas like number, subtraction, place value, fractions, we have to gradually build up these networks of connections where each new experience is being connected with our existing understanding and related in some way to other experiences. And it's achieved through practical engagement with mathematical materials, through investigation, exploration, through talking about mathematics with the teacher and other learners, through teacher explanation and asking the right questions. So Derek Haylock, and that's come from the book Mathematics Explained for Primary Teachers. I highly recommend that book. So the teacher plays an important role, all right? It's a crucial role because obviously we can just send learners away to go and play with the equipment, all right? But it's that explicit teaching, all right? Teachers recognizing, noticing, they're questioning, they're listening in the moment, all right? Which is obviously also from the new curriculum document, that notice, recognize, and respond. And teachers help learners to make those connections from those 4 components that I just shared, okay? Think boards are another really great way. If you just type think boards into Google, they will help you use those 4 components. All right, teen numbers. So this image is one that I would do with my learners at the start of I used to do it at the start of the year when I was in the classroom, and I would ask them, what do they see and what do you notice? So Trish, I'm going to ask you that question. What do you see and what do you notice?
Well, I see it's a growing pattern, and I can see when you get to 10, all the 10s are on the bottom, and then the ones or the smaller numbers are on the top.
Yeah, the coloured ones sit on top.
Yeah.
That's very great observation there, Trish. So teen numbers, learners need to actually see this visually. And my boss, Margie, when I first started in this role, she said to me, teach teen numbers backwards because they're more than likely going to make a connection not like they would with 11 and 12. Okay, so if we touch the 9 and say 19, 18, 17, 16, 15, it's not until you get to that fifth. But if they know the ordinal sequence, first, second, third, fourth, fifth, you can hear it. 15, 14, third, I came third in a race, 13. Now with 12, it starts with a TW, I suppose, 2 and 10, 12. And then 11 is Old English for Elofan, all right? And which means 10 and 1, and it's just morphed into 11. So the other really important point, which is in our New Zealand curriculum about explicit in year 2, we need to be teaching our learners explicit base 10 in Te Reo Māori as well. And I would highly recommend, I did it with a classroom, I modeled it last week, and I did it in Te Reo Māori, and I often do it, te kau mā tahi, te kau mā rua, and touch it as I say it. And they notice that in English, we touch the coloured ones first when we say it. And in Māori, we touch the tens first. So we're saying 10 and 1, 10 and 2, 10 and 3. And in English, we're saying 3 and 10, 4 and 10. So hence why it's very easy for learners to write 31 for the number 13. We know that now. That's a sequencing issue. So the other, I'm just going to stop share and demo. I've got some pegs in front of me. When you are teaching T numbers, you can use wrapping paper or whatever you've got. Otherwise, counters, well, these are called pegs because these fit into the Pneumicon shape. So I would just place a pile of these on the table and ask the learners, if we weren't going to count them, how could we arrange these to know how many we have? All right. So then we would come to the agreement that we would be grouping in tens. All right. We're going to group into tens. And I'm using 2 hands because I don't want learners to count. I want them to just see the pattern. And I can prove that I have made 1 10. All right. And I've made a 4 pattern. So here I've got 1 10 and 4 ones. Te kau mā whā. All right. 14. And then I can place it into my 10s and 1s. All right. I've got 1 10 and 4 ones. If I ask the child, once again, I did it last week and I asked how many ones, and the child looked at me confusingly. And I said, how many ones? And that's when they said 4. All right. So you will have to repeat that. I can exchange these 4 ones for a 4. And going back to that previous task that we did, that would be really helpful to do that with your ones. Okay. So actually making them up with ones, because that's your place value starting there. Yeah, and then finding on a number line, where does 14 sit? Okay. And I can actually see before, when you saw it on my screen, I had it like that, a 10 and a 4 on top. And that's for showing relationships. I wanted them to see that the ones, all those colored ones, it's just a pattern. The colored ones start again. But when you're writing, when you're working on place value, you want them next to each other, because that's when you're writing them down. We've got 1 10 and 4 ones, and we say it 14. And I touch it as I do it too. So that's place value. Now, 14, I would highly recommend, obviously writing, I would write the number 14. Then I would switch those digits around and I would say, how do I make 41? All right, 14. And then I'd write 41, and actually showing them the difference between 41 and 14. There's 41. All right, I've got 4 10s. and 1 4. 4 10s. And when I stack them on top of each other, obviously I can write them a lot. It can be a bit clearer. 41. And I would say questions like, what's 1 more than that? What's 1 more than this? And then I would ask questions like, what's 10 more? 10 more than 14? Oh, 24. I did it last week in a class, and the learners, yep, they got it. So, all right, I'll just share my screen again. All right, with Cuisenaire rods, you can see, same again, how it can be done. Place value 10 ones is equivalent to 110, just like I demoed. All right, that 4 ones is equivalent to 1 4. 2 10s and 6 ones, and then I've put those 6 ones as ones to the side, just to remind you that you may need to use the orange ones until the learner is understanding that concept. With the rods, 5 ones is equivalent to 1 5. All right. And then I've got there 4 10s. You can see the pink rod on top of those orange ones. It actually tells you how many 10s you've got when you place it that way there. All right. And then 4 10s and 5 1s. All right, addition. So we're moving into addition now. So all the words for addition, when we think about adding, that sign there, the adding sign, it's plus, it's combine, it's join, it's addend, it's sum, it's total, it's increase. And when we think about the structures of addition, we've got aggregation, putting together, okay, or combining. And then augmentation is you've got an amount and then you're increasing it, okay? I'd like to now demo a few addition. All right, so in front of me, I didn't actually make one. We're going to make a 6 sandwich, okay? So my base of my sandwich is a 6. I then start with my smaller shape. What's the difference in there? And after 1 comes 2. Oh. After 2 comes 3. After 3 comes 4. And after 4 comes 5. And after 5 comes 6. So I have made a sandwich with layers, okay? And I've worked systematically. All right, what do I mean by that? I've worked systematically by starting from a smaller shape. I started with, obviously, the 6 shape. So, Trish, what could my number sentence be to my first layer be?
Your first one could be you've got 6
Yep.
plus 0 plus nothing more.
All right, 6 plus 0 equals 6. Right, what was my first number I used?
You use the little one, number 1.
A 1.
1
plus 5
equals.
And then I did a 2.
Plus 4. 3 plus 3. 4 plus 2. 5 plus 1. And then 0, but you had to add a 6. 0 plus 6.
Oh, I was following a pattern. Do I have to make any change?
No, you don't. Sorry.
Yeah,
you're right.
What I do here? Would I change that to 0 plus 6?
You would change that to 0 because you didn't have anything to start with. And you added
right. And yeah, but that's what learners do. They actually find the pattern and they go, oh, that needs to be 0. So it's a really great way for learners to see that mathematicians work systematically for a reason. We want to know that we haven't forgotten a combination, okay? So 0, 1, 2, 3, 4, 5, 6. And then I can look here and go 0, 1, 2, 3, 4, 5, 6. And then obviously our total. I can then ask them, could I write it like this? 6 equals 2 plus 3. 6 equals 1 plus 5. All right. And when you've done that explicit teaching of equivalence, then they don't go, no, that's not right. All right, because what happens on that side is obviously it's all balanced. Its total's the same. The other really important point to make, obviously addition, like we talked about, is joining, and then subtraction, separating. I've got these subtraction covers here that you can use. 5, take away 3, and then learners can actually see that it's made the pattern of 2. Okay, so they're not having to count, which is really, really important. Number trios. Okay, so I highly recommend, and inverse relationships, it is all through the new curriculum, which is fantastic. Inverse operations undo each other. All right, it's under the no section of noticing properties. So I'm just going to use some smaller numbers so I can fit them in my circles. All right, so 3 is my total. Okay, what can I place in there to make? All right, so 1 plus 2 equals 3, and also 2 plus 1 equals 3, so the commutative property. I can then write my family of facts, which is also in the new curriculum. It's asking them to be able to write their family of facts. I can change this to dollars. All right, I've got a total of $3. Look, here's my empty number problem. Got a total of $3. I've spent $2. How much do I have left? Okay, so there's your empty number. Really great for those. And then, oh, bonds, that's right. Bonds, you can see when you join, I know I'm coming up to the end now, it's nearly 10:30, but I've still got a few slides that I want to share with you. So I might just do the multiplication instead of going back in and sharing. 5, 4, 3, 2, 1. If I join 2 staircases together, all right, just like with the Numicon shapes, if I had this staircase and then I ask them to join another one, all right, you can see I'm making my bonds to 10 if I want them to be worth 10, which I'm going to share with you shortly. All right, and there's a pattern, another pattern happening here. Three, 2, 1. Right, red and brown and green and black. There it is. Okay, so there's my bonds, and remember you can do that with shapes as well, with the Numicon shapes, making my bonds to 10 by joining 2 staircases. Now I can say that if this is worth 10, then what are these layers? Okay, if this is worth 100, then what are these layers? If this is worth 1,000, then what are these layers? If this is worth 1, then what are these layers? All right, so that's why these rods are fantastic, because they don't actually have to be what you think they are. And this other activity here, using the rod trays, all right, this tray is fitting in a yellow, okay, so it's they're so the green ones fit the green rods and the yellow ones fit the yellow ones. So I've made each layer, okay, so I can say this is what they call the name game. Okay, so if I want to call this yellow, y, and I'm going to abbreviate it, y equals y, and then w for white, w plus 2r equals yellow. And I could do w plus w plus w plus w plus w, or I could do 5w, okay? Yellow, y equals 5w. And then here I could do y equals g plus 2w. And then y equals R plus G. All right. So really, really neat game. And then I could change it to actually that's worth 5. I could change it to that's worth 50. I could change it to that's worth 1. So if this is 1, then that's going to be 1/5. 1/5 plus 2/5 plus 2/5 equals 5/5. So really neat game to play there. With multiplication, okay, I've got them prepared in front of me here. So thinking about commutativity, like on the addition that we did. All right, I've only got, 4 plus 2 and 2 plus 4 equals 6. It's commutative. I can switch them around. Just slight multiplication is commutative. So here I've got 5 4s. And if I wasn't sure what that rod was worth, I could place them in there to see that it's worth 4. 5 4s and 4 5s. Are they going to make the same area? Yes, they do. All right, and they also end up making the same length as well. But I'm running out of time. I'm going to stop, share my screen and just quickly finish off my slides so that you can ask some questions. So there's the commutativity. You can see it actually makes the equals sign, which is quite neat. You've seen the 2 rods joined together, the 2 pneumicon staircases joined together. You can see doubles. All right, that's also mentioned in the new curriculum, knowing doubles. You've seen the name game that I just shared, the inverse relationship. They can be used to teach negative numbers. Multiplication and division, which I've just showed you with the rods, and it can be shown with the pneumicon shapes. Factor diagrams, all right, and seeing that factors are obviously only got 2 prime numbers are the ones that only have 2 prongs. Square numbers actually make a square, and then when you shade them, they make that diagonal. They can be used for perimeter, area, division with remainders. There's a game on a video there that I can share with you at some other time. Fractions. Okay, I can place a 1 rod on top of a 3 and write it as one of the 3. Okay, I can look at equivalent fractions with rods. All right, quarters. How many quarters are equivalent there? Fractions of amounts. Algebra, what's the missing shape? Okay, and it's B for black. Algebra. And another quote from Derek Haylock: if we as teachers aim to promote understanding of mathematics rather than just learning by rote, then the key is to teach it in a way that encourages children to make connections. And I'd just like to finish with a whakatauki. Ka rongo, ka wareware, ka kite, ka mahara, ka hangaia, ka marama, aho. I hear, I forget, I see, I remember, I do, I understand. And that is a monument in Hamilton of Cuisenaire rods. Stop share. All right, I'm going to unpin my video.